Welcome, very good evening. Hello, Bondhura. This is Jakir from Dhaka. Welcome, everybody. Water Chemistry Live class with Jakir from Dhaka, Bangladesh. Thank you very much for connecting me, encouraging me, and helping me to continue this class. Today is day 44. From day 1, we stand on day 44. It's a very long journey. And we started with the basic water chemistry. We completed different parameters of water. We discussed the dosing calculation of different units. We discussed the effects of water in different system. What could be the effect for water? What could be the problems? Thank you very much. Thank you who already connected. And today, as per our schedule, today might be the last class for internal water treatment, as we discussed and we completed the discussion regarding the corrosion, scaling, biofouling, fouling, and biological problem. Thank you, Arif Ahmed and Bayajid Hussain. Welcome. I'm really honored having you all, and I'm really facing actually a lot of technical problem regarding the Facebook, my pages, my main accounts. I'm having a lot of trouble from Facebook, so that's why I have to use a different account to continue the journey. So can you, Arif, tell me, can you hear me clearly, and can you see my screen clearly? Can anyone just thumbs up? And thank you and appreciate you all for continuously hearing me here. So I can see the comment on JTZ Buckman accounts, as I am going this on JTZ. So thank you very much. So today basically I like to wrap up the discussion, and I like to close the discussion on the application part of the biocide, and those are the very important. And from my experience, what I found, most of the system is fouled badly, and most of the system having a problem on microbiological problem and fouling. Yeah, thank you very much, Arif. Thank you. So if you see, the discussion started with the basic water chemistry. We continue the discussion, and we are standing on internal water treatment, and we discussed several times that in internal water treatment we control especially 4 problems, or we encounter 4 problems, that as a nutshell we say BCS, that is biological problem, biofouling or bioorganic problem, corrosion problem, and scaling problem. We are standing on biological problem. We discuss a lot on the different kind of algae, bacteria, fungi, legionella. We discuss the fouling. We are discussing on the control of organism. And the control of organism, we discussed couple of classes: the strategic control, environmental control, physical cleaning, and chemical control. So these 4 kind of approach only able to control any microorganism control for a system. If we fail to control strategically, if we fail to control environment, if we don't entertain physical cleaning with a defined schedule, if we depend only the chemical control, most of the time it will be very tough, and it is a probability of success is very low only based on the chemistry. So that's why I like to focus on more classes on microorganism control, and because most of the system, as we found, fouling, whether it's a mild, whether it's a heavy, or whether it's a internal side or external side, we found there's a lot of fouling and microorganism in the cooling system or in the other system also. So here we like to highlight it again. This is very important graph. We have to understand the physical cleaning requirement based on the graph, based on the system outlook. If we understand the microorganism growth stay above the lag phase, like at a log phase or a stationary phase, believe me, chemical can't clean this stage. The system will remain always fouling, and definitely we have to have a plan for a physical mechanical cleaning. Then again chemical will work at the lag phase. So if we miss and still if we try to control using chemistry, it is really next to impossible to keep the system clean and control the microorganism. And we discuss this again, the chemical, especially we use a chemical that we call biocide and biostate. Biocide, those are kill microorganism directly, and biostate, those are inhibits. And in biocide we found oxidizing and non-oxidizing biocide. All together in the market they call people biocide or many other trade name. I just wrap up the back classes so that you can connect me. And we use commonly a lot of oxidizing biocide. Those are very vulnerable with the environment, dependable with the environment, and a lot of disadvantage, like those are pH dependent, sunlight dependent, a lot of other factor dependent. That's why many things is the oxidizing biocide is not functioning properly, and because of the insufficient, because of the higher demand in the system compared to the dosing amount, all the time we found algae growth, all the time we found slime growth inside and outside or nearby the system. So that's why we have to be very careful. We discussed this very detailed earlier classes. If you miss, you can watch the video 41 day, 42 day. We discuss this kind of things. And again, on the non-oxidizing biocide side, we have a two kind of chemistry as a depending on the function. We discuss them, we call them metabolic poison, and we call them surface active biocide. Thank you very much for connecting. Thank you, Rohul Amin. We are discussing the water treatment, water chemistry, and today our discussion topic is control. So we discuss very detailed how metabolic poison work, and we also discuss the different kind of functional chemistry, group of chemistry, those work as a biocide. And the left side, the red table, if you just for review, there are a lot of chemistry starting from quaternary compound to organic thiocyanates. There are a lot of chemistry we discussed very detailed earlier class. Again, we also confirm that only biocide chemistry that we shown here in the left side table alone can't control, can't perform perfectly, effectively, efficiently. We must have to have some biodispersant or dispersion with this, either in that same formulation or independent chemistry, to help the biocide to work perfectly, to kill the bacteria, to attack the bacteria surface. Unless the bacteria surface clean, biocide can't work with the bacteria cell. So that is why very important to combination of the system. Yesterday class we discussed again on the selection of the biocide, how we can select the biocide, and it is always we have to be very expert to selection without being the professional experience. Expertise advice. If we just pick any biocide by any small or little knowledge, then the chance of failure or chance of wrong selection always be very high. So if you want to select any biocide, definitely we have to be consider water chemistry and different organism and the fouling chance, and as well as the environmental aspect. And the chemistry we select must be efficient at different spectrum. It must be stable with the other environmental factor, temperature, pH. It must be compatible with the other chemical, because all the time we have to use multiple chemicals, and must be economics. So today we like to again highlighted, yesterday discussed the things that is very important, method of application. We have to be understand the amount of dose for the product we selected as a biocide. We must to understand what are the method, like should I dose for continuous, should I go for intermittent dose, and should I go for the shock dose or slug dose. We discussed very detailed, and yesterday on this slide we must understand the frequency of the dose. We may higher frequency or may lower frequency, but this is also very important. We must understand the feeding plan, feeding point, feeding mode, and definitely all the biocide and all the chemistry are a bit hazardous. So you have to be understand and set and design the handling plan. Then only we can safely dose and safely apply the chemistry, and we will get the result. So here the part that we discussed yesterday stop here, and we will discuss today. This is the important the growth mechanism that we understand earlier, the graph. The graph is because of the bacteria population dynamics graph. We classify them lag phase, log phase, stationary phase, and dead or declining phase. So once we started our dosing, there is a very important, once we dose biocide, once we select the biocide, so how we can control our organism growth below the lag phase, or are we capable, or are we doing right choice, doing right biocide, or having the control. The graph is showing. If you see, the top is the general or normal growth curve, normal the dynamics for a bacteria, and if you see the below the line, that is the chemical treatment. So if you go for a continuous treatment, like if you go doing biocide dose continuously, especially thinking for oxidizing biocide, like can think for a chlorine, can think for a hypo, can think for any chlorine dioxide on the H side generation. So if a system having continuous biocide, then the curve for the bacteria growth remain very strong and stagnant up to a certain days at least. So continuous biocide dosing have a very good advantage and control of the microorganism growth below the critical population or below the lag phase. And if we really can do this kind of control, means my bacteria number always below the some design number. It may be less than 10 to the power 3, it may be less than 10 to the power 2, or it may be always less than 10 to the power 4. Whatever my desired design, whatever the critical population I select for a particular system, for a particular product, for a particular chemistry, that is achievable. Like if it is a critical population, if you see this graph dotted line, this is the critical population, this is the target, that for any system or any chemistry we design, we will not allow biocide to grow above this level back, because this is the lag phase, and above the point it become log phase of the microbiological growth. If we understand the earlier classes, we always advise and prefer our microbiological control, we want to control in lag phase. So this is the point that the lag phase is finished. And if we see the biological growth number, this is the critical population number. So if we want to be successful to controlling microbiocide or controlling microorganism in any system, we can't allow the number of microorganism at any point of time in my treatment system around the year, we will not allow to grow above the number. So if a product gives the result something like this is the number, here is a much lower than the critical population number, but a certain time it's very straight, after a certain time it go up again. If we understand it's growing, if we can slightly increase the continuous dosing, again it will come down and go, and then go further. This is a very good example for a continuous dosing biocide, where we can keep the organism very well controlled. And that's why oxidizing biocide for a big system, we always prefer to dose continuously, or at least we can dose for intermittent dosing, maybe morning and evening, or maybe for a small system every day at evening or every day at early morning. So what happens if we dose every day, like for 24 hours, the number should remain every 24 hours here. Again it's slightly going up. Again if we dose again after 24 hours the sufficient amount, right product, then again it come down on the same level, and it continue again another 24 hours. So 24 hour it's the intermittent dose. And if we dose intermittently, or if we dose continuous for any good quality effective oxidizing biocide, the system microorganism should remain in this range. If really we can control the microorganism number for any system like this line all the time below the critical population, then my system will be clean, my system microbiological control will be very good. There is a less opportunity to having the slime, less opportunity to helping scale precipitate material to come and sit down on the low flow area. So this is a very important graph, and for producing this graph we have to monitor the bacteria count, we have to understand the bacterial growth, we have to understand before after dosing, and we have to continuous monitoring the biological number. That's a big challenge for us. Usually for system we might not monitoring the biological countdown, and that create we don't know how much biocide we are dosing, we don't know where we are standing, we don't know biocide is correct or not. There is no monitoring, testing or monitoring of application or activity or performance of biocide, and that's create the problem for the system. Even if we dose oxidizing biocide, we don't have any opportunity to test the activity of the oxidizing biocide. Is it functional or not functional? Is it effective or not effective? That are the major challenge for a country like Bangladesh, people like the customer like us, and supplier like many of us. We can't have the control and measurement and monitoring that keep us in dark. So really, if we want to control, we need to be control our total microflora or microorganism population all the time below the critical parameter. And this is a example of a continuous or intermittent effective good quality sufficient dose biocide. If we can dose oxidizing continuous and intermediate good quality dose, we can have the graph like this, the bottom graph. And if really we can want to achieve a good practice, we have to stand here. Guys, if you have any questions so far who are watching, you can ask me. Because of time I am going fast, and if you have any concern, please you can raise your hand and you can ask me anything. If you see this graph, this is another very important. The similar the bacteria growth curve, general curve without any treatment. Here is the log phase, stationary and decline phase. This is the critical mass, that critical number. We want to have our practical number below the critical mass. And if you see the graph here, there is a two graph. One is graph A, another is graph B. So if you see the bacteria graph is a kind, you give a dose like a slack dose or intermittent dose or frequently dose, like maybe once in a week. If you dose sufficient enough, and if you design, you want to control your biocide below the critical level. If you dose, for example, the 0 day, just this chemical dose is here, so your bacteria is here. If you see the bacteria started growing after certain days, maybe after 6 days or after 5 days, if you dose 7 days interval, so after 5 days the bacteria started to grow slowly. At that point, you again chemical dose is here. So if your chemical is sufficient, effective, and your system is clean before starting the chemical, then it is always very good for everybody. The system will be under control. So once you dose again the biological growth come down, and it's like a graph it follow. If you dose, then it is a certain day, the bacteria is a below very low number, but after certain day bacteria started again grow slowly. And again if dose, again it come down certain time below the level, again it goes, bacteria started to grow here, and then again here. And if you see the A curve, very good curve, so that means everything is well controlled. But if you see the B curve, after a certain continuous dosing of same biocide, maybe for month and month, year and year, sometime the biological or bacteria resistance growth. The same biocide at the same amount dosing, if you see the B curve, the same dosing is starting from here, but after certain day it started growing here, but it grow further much, and again it come down. The dose this point here, again we dose again this day, like maybe 10 day or 7 day. After 7 day again we dose the same chemistry. But if you see the growth pattern, the A curve, the B curve is more. That means the level from here for B curve, the level go up. That means again we dose, but it dead. The bacteria die, but the growth pattern is more than the dead pattern. So bacteria number is upper is here. So if you see the point is here and point is here bacteria is more the live bacteria is here, and less the live bacteria is here. That means this is the gap, this mass of bacteria grow with the resistance. That means they are not dying with the same biocide. So with the same dose for the same system, some of the bacteria is still alive and they become resistant. And if you see if you dose at the next dose, they again some bacteria die. They die this part, but again they keep growing. And at that point again, if you dose another dose, some bacteria die. Equal amount of bacteria die here. But because of the resistance, some bacteria always remain safe zone and they reproduce more. So once they reproduce more, the total accumulated number is growing up. If you see here, the curve is going like, if you see the dotted line, the bacteria is growing up. But if you see this after a certain frequency of dosing, if the resistant or the bacteria who already adjust or adapt with the biocide that we are dosing regularly, if it stand at a critical level at that point, after a certain month, after a certain dose, maybe after a year, then the same biocide may not work, the same biocide may fail. Sometimes customer may complain your product may be bad, before was good or something like that. So this may not be because of the chemistry, may not be because of the product, because the bacteria resistance develop and the bacteria is not dying because of they adjust with the chemistry. They understand the mechanism of the biocide, how the cell is structured they destroy, how the cell is structured they kill the bacteria, or how they work with the bacteria. So bacteria understand the working mechanism, and bacteria may resist, or bacteria may different strategy to grow, to survive. And that's why this curve is very important. If we don't understand and if we don't monitor, especially for bigger system, for fertilizer, for refinery, for big cooling system, we always do check this kind of test where we monitor, are my biocide is going to fail, or when my biocide is going to fail. So that's why people used to use alternative biocide. Thank you very much, Saddam, but you late. Alternative biocide. So once you have this kind of experiment, this kind of system, then definitely, and this kind of graph also indicates us we need alternative biocide. That means we have to have alternative biocide in our list to actively work against the organism growth in any system. So this graph indicates very clearly how we dose and how bacteria die, and again how bacteria grow. Again we dose, bacteria more die, again bacteria grow, again we dose, bacteria die, again we grow. So I try to explain very easily, guys. Thank you for your patient hearing. If you have any question, please do ask or write on the comments. And this is very important, because many of our system, or many of the customer, or many of the industry, they are facing the microbiological fouling problem, but they are not getting the solution, or they are not get rid of this kind of problem. Neither they are understanding the mechanism, nor they are listening the changing chemistry, or not they are having the sufficient stock, nor they are giving the enough doses, nor they are doing the physical cleaning, nor they are planning for strategically to control. They only depend on the one chemical, they only depend on the one biocide. So most of the cases, because of this reason, they are failing. And because of this mechanism, it is proof that if we don't follow the graph, if we don't follow the total overall control strategy, only chemical can't help. Sometimes chemical is only because of the 20% problem may be solved, 75% problem remain. So 75% always greater than 25%. So the effectiveness is reduced, and after certain time, after certain month, after certain year, the system is fouling become visible, and ultimately they say chemical is not working. This is a total strategical fail. This is not only chemistry fail. So guys, if you have any question, you can ask me, you can write there, and I can touch your question, and I'm sure you can understand this graph very clearly. Thank you very much, Saddam, Ruhul Amin, Sentu, Shadot, Arif. Still, if you have any question, you can please ask me. I am closing this treatment or internal water treatment today, because we have discussed most of the topics, corrosion, scaling and biocide, and today is the last discussion on internal water treatment. So I will allow you, if you want to ask any question on internal water treatment, you can also ask me. You can write on the comment now or even later, so that I can discuss this also. Thank you for patient hearing. So if you see, I have a few of slides for the special consideration. Many of the cooling tower, many of the cooling system is specially made by wooden structure, and especially for a bigger cooling tower, for fertilizer, for power plant, even for many other process industry, we found the cooling system is developed by the wooden structure. And this is a very good, and this is very wide and widely acceptable design. But the challenge for wooden structure, we have to do some special care for wooden structure to maintain the cooling system safe and cooling the structure safe for longer time. And that's why I have just highlighted few points here to special attention for the cooling system where the wooden structure is available. Number one, if we have a wooden structure, we have to be initially do some kind of treatment, and initial protection is very important, because if wood or any kind of cooling or structure, especially if it is wooden, and if any problem is started or wood rotten is started, so then it is very difficult to control the rotten, because normally wooden outer surface is the most important part. Outer surface is most critical. If outer structure or outer surface fail, inner surface is less resistance to the vulnerable microorganism environment. So the outer surface, we have to be very clean, and it must be pre-treated. Usually for wooden structure, if the designer or supplier is very good, they always treat the wood by pre-treatment by fungicide. So if the wood does not treat, or if it is not treated before developing the cooling tower, it is always vulnerable, and that cooling tower and the supplier is not good, professional enough. If the supplied wooden are not treated fungicide by any good chemistry before installing in a cooling system, definitely the cooling wood will be rotten and damaged. Thank you, Mohit. Thank you very much. Thank you. Today we are discussing microbiological application for water treatment, and we're standing day 44. Thank you for joining. So that wooden and every structure must be pre-treated very widely and nicely by professional company or by good quality fungicide. So we have to be remind our customer, if you want to set up any cooling tower having wooden structure, this is good, but definitely make sure the supplier must be give the wood that is pre-treated by best quality fungicide, so that it can withstand with the organism during its operation. And after installation, the system must be kept clean. All the internal external cooling structure, the wooden structure must be clean. It must be cleaned by using chemistry, strategic manner. It must be cleaned by mechanical cleaning. It must be cleaned by periodic maintenance cleaning, but it must be clean. We can't keep a surface under slime, under contaminated microbiological for long time, like 6 months to 1 year is a very dangerous time. And there must be a plan for every year cleaning. We must be control good quality oxidizing biocide. We must control sufficient free chlorine, and we must control and monitor the health of the wooden structure. And if we want to control the pH, the acid, if we want to dose acid, we have to be very careful. We should not use acid directly with the contact with the wooden structure. We should feed acid in such a way at a certain distance where the diluted part of the water or contacted with the wooden structure, so that the outer surface should not be affected. And we must inspect the cooling tower once in a year, very detailed. And if we found any problem, we must do maintain, and we must repair with the treated wooden. If we do not use the treated wood for the repairing, for the breakage damaged part, again it will create problem for the whole system. So we have to be very careful, and we have to be inspect at least once in a year to understand the condition. If we found any observation, definitely we do take care for that part. And finally, we must be take care for the microbial induced corrosion control as a part of the organism or microorganism control. And if we want to keep system free for MIC or microbial induced corrosion, we have to be take two kind of special measurement. One is a prevention, so that my system is proactively prevented from the chance of or probability of having MIC. And if we have understand some MIC already developed, then we have to do some protection and stopping to further deterioration. So in the part of prevention for microbial induced corrosion, the fundamental thing, system must have the treatment with the dispersion, biodispersion. That means we need to keep the system clean. We can't allow a slight deposit, we can't allow any kind of slime, any kind of suspended particle, any kind of fouling, because if fouling is there is a probability of MIC. So we have to have the dispersion in our treatment. And usually we must or we should have coordinated treatment program. Coordinated treatment program means good quality corrosion inhibitor that is coordinated, the part of a synergical scale inhibitor, and it's a part of a synergy of a biodispersion or dispersion, and it's also coordinated, integrated with the microbiological treatment program like oxidizing biocide, non-oxidizing biocide, or multiple product. That means the treatment must have a coordinated approach. Treatment have full focus or optimum focus on corrosion, scaling, biofouling, microorganism fouling, oxidizing, non-oxidizing treatment. So all the coordinated treatment for any cooling system only can prevent MIC and definitely prevent of deposition of suspended particles. So you have to be take care at pre-treatment, take care of the side stream filter, so that the less chance of suspended particle deposition. So all these three is a vitally important as a prevention for MIC. And if already some MICs happen because of the mistakes, then definitely we have to flush out the loose debris. And if it is a rust, sometime we might stop the system, sometime we might to go for the chemical cleaning, because it's vitally important. If we don't care, then definitely my heat exchanger will be fail, my tube will be leak, big damage will be happen. Maybe I have to change my heat exchanger, maybe I have to shut down my plant for a long time, unwanted shutdown that may create a lot of challenges. And definitely we have to be do very good passivation and initial treatment. Sometime welcome Imam Hasidur Rahman, thank you very much. Sometimes we mistake, we don't care about the passivation, we don't do initial flushing and treatment, we don't treat even after shutdown. So like during corona period, many of industry is in shutdown. So if we want to restart again, so we have to do initial flushing and passivation. If we don't do this, definitely I will not get the optimum control of corrosion, optimum control of scaling, optimum control of many other things. So that's why it is very important initial flushing and passivation for every on off of every plant. It can be boiler, it can be cooling tower, it can be any system. If we want to run after a certain stop, after a shutdown for a maybe couple of months, couple of days, couple of weeks, then definitely we have to go for flushing, passivation. It's a mandatory, otherwise we might have problem in long run. So these are the some tips, and that's how we concluded our internal water treatment, guys. And I am just end of the slide. So by this discussion today, I am finishing the internal water treatment. And you remember we discussed very detailed biological problem, corrosion problem, and scaling problem. In a short, we call them BCS. I try to explain in detail as much as possible, as much as crude information without disturbing any patent, without disclosing any company's secret information, without disclosing any competitive information. I stand here as a last discussion of internal water treatment. If you have any question, any comment, any feedback, you can comment right now, or even you can comment later also. I pause for a couple of seconds for you all to having your question, and I'm waiting. If you have any question, you can write here, and if you don't have any question, I request you all, those who joined today, we have 44 video including today's video. You will find this video on YouTube, water chemistry by the name. You can find this on Facebook, water chemistry live page. You can find on water TV group or water TV page, and you can find me on JTZ Bachman last couple of classes. I'm facing a lot of problem on using Facebook, so today is the internal treatment discussion as a last class. I try to connect again tomorrow if I can have the chance, and we will discuss on different topics. You can advise me the topic you want to understand. You can ask me the question. You can choose me any topic to discuss on water treatment in any subject. I can catch on that. If not, then I will come on another topic on same JTZ Bachman account, as I can't access my account as widely because Facebook take accounts for other things. So by the time, stay connected, stay strong, be happy, and keep your learning curve high. And thank you very much, and good night. Assalamu alaikum. Take care and keep praying for me, and keep praying to you all in this Ramadan. Thank you very much. Assalamu alaikum and good night. Bye bye.